Welcome to another episode of Unity URP Lighting here at LightingBot. My name is Amit. I'm a senior lighting artist at Interior Night at the moment. I use Unity and Unreal Engine on a daily basis. I'm here to teach you the concept of lighting artists by also including theory and showing how it practically works and kind of explaining the details of becoming a great lighting artist. So you can make your portfolio stand out, you can get a job as a lighting artist, and you can really create your game to be optimized as well during this course that is free for you guys. At the end of previous video, I gave you a challenge to tell me how you would sort out the issue with the indirect lighting occurring at on this character. So if I bake it, you can see it lights up the environment because the environment is set to static. So when you set something to static, it will bake it and it will bounce it around. So you can look at the faces here, especially this one, and let's do Control Shift S, or is it Control Alt Shift, or is it Windows Shift S? Right, so let's just do this very quickly. Let's put it there for reference, and let's do a quick general lighting. And you can see that not a lot happened. Now if I do Contribute GI and we do another general lighting, let's have a compare. It's okay, something's happening, it's going through something. You can see it's only this one that's going through a lot. And now you can see it's a very subtle difference, but that's why we are making this course. It's so you can actually learn to see the difference and understand the difference, and actually go, okay, something is wrong, or this doesn't look right. Look at how it's smooth and it's gradient now, rather than this one, which is actually pretty flat. So when I say it's flat, or someone tells you it's flat, this might be one of the reasons. So this one is set to be static. So what are light probes and what are they for? Well, in real life we have the directional light, as in the daylight or the moonlight for that matter. What it does, it casts light everywhere, and it also casts indirect light. It's a very powerful light source in the real life. But on top of that, you also have indirect lighting from environment. If you're taking a run, you have the daylight bouncing around, but you also have light from the environment itself. And then you have harsh shadows. So when you run through the harsh shadows, you still get some light on you. So how do you solve that without being too expensive, in the sense that the games have to be optimized, they have a hardware limitation and software limitation. Now, there are situations when you're outside and you're doing lighting for night. How do you make sure that the cars are well lit indirectly as they're set to movable? And how do you deal with movable objects such as cars and people running into the shadow areas and out of the shadow areas as you need them? So that's why we have light probes. It solves that problem, especially in the URP lighting. So ignore ray tracing and other topics for now. Okay. Now the challenge with having this kind of lighting is that maybe you don't want it to be static. Maybe it is moving, and you have other challenges where you're not getting the indirect light that you want for the characters that are moving. So let's talk a little bit about light probes. Light probes, they are generally meant to capture the lighting in the environment in such a way that when you light the environment in baked, it will capture the lighting of the surrounding indirect lighting that's being baked, and it will then cast it on the characters, right? So let's just try it out for a bit, just for the fun of it, right? This is a movable character, and let's say I want this to be more, let's keep it white. Let's do another light. We've gone through these type of lights before. Let's cast this light to be around here. We don't need any shadows. Let's do baked. Let's do quite intense. And let's make this super blue. Okay. And let's do the same about here. Cool. Actually, let's just do it like this. Alright, and let's do general lighting bake. Now, you might notice that this particular character is quite a lot more blue. Now, if I click this character and I pretend it's moving, okay, it suddenly goes into blue and it goes out of the blue. So if I go for this one, you see not a lot is happening. If I go in here, something's happening. So that's basically light props. So what light prop does, it allows you to solve the challenges of your lighting when you are having issues with indirect lighting not being cast on movable objects that are not set to be static. So we are not setting it to static, so therefore we want to have light props so they get the desired indirect lighting that they need, right? So that's how you use light props, and that's how it solves a lot of your issues. So you would generally have light props around the whole environment, or at least spaces that goes from dark to bright as well, right? So it's not just about the colors, just to emphasize that. So if I put some light prop over here and I do new generate lighting and I move this one, you can see it becomes darker, right? And it captures the different tone. Now here you can see it becomes brighter. Now why is that? It's not that much brighter over there. Or what happens if I go there? It stands out. That's because it's not having the light props to keep adjusting as it goes into one environment that's dark or brighter or have a different color. Okay, so that's the value of light props. So what we're gonna do is I'm gonna pause the video quickly and actually place out the light props. And I place some basic light props around. It's not perfect, but it should do the trick. So if I now do light bake, you can now see this one has a more controlled lighting on it, and you can see that this one is also having its shading done correctly. So it's very important how you place the light props and the distance and the amount of it. Otherwise it will take the 4 to 6 closest light probes and it will brighten the area. So if you have some bright areas like we had earlier, or you have some issues, it's basically quite often the placement of the light probes. In fact, if you watch any of my other content on my private channel as well, you will notice that if the light probe is outside, you have sunlight and it's super bright, and you're inside and it suddenly is bright around a corner or a shelf or something, often it's because there's a light prop outside the wall or on top of the roof or under the floor and stuff like that. Okay, so that's that. Now the second thing you might notice is when I clicked is reflection probe. So let's talk a little bit about reflection. So what are reflections and why do we need reflection probes? Well, there are two types of reflection. There is anisotropy and there is isotropic. Now, anisotropic surfaces are something that looks different based on which angle you're looking at it. So if you rotate something that has an anisotropic property, also commonly known as specular reflection, it will change its look. But if you have something that is isotropic, it doesn't matter where you move around the room, it will still look smooth and reflective or plastic-like. So as I said, in our work term, we really call it specular reflection. So we're talking about on shader level. So you might have a surface which has a glossiness value of 30 or specular level on 30 in one direction, but 90% of the light is reflecting in a different direction. So that is more like how anisotropy would work. On water and mirror, those are a type of reflections that would definitely reflect on 90 degrees. So when something hits 90 degrees, it will have a mirror reflection. If it has a very smooth metallic surface, you get more of a specular reflection because of the smoothness. Unevenness, you might call it diffuse reflection. So we call it different things, but in this context and for the sake of this topic, that is why we need the reflection probe. It helps define the direction and the level of reflection you need for your object materials, basically, that are have the property of a metal. So the darker it is, the more rougher it is, the less it reflects, and the more smoother it is, the more it will reflect. Okay, so hopefully that's also useful to understand as we move into Unity. Okay, let us talk about reflection probes. I just added some more stuff for visual pleasure. And reflection probes, what you want to do is you want to make sure that the reflection probe is on here. So in this case, what I've done, I've selected everything and just clicked everything for ease of use. And I'm gonna do a quick generate light. Okay, so all good. I'm gonna right click and I'm gonna put in the reflection probe. And I'm gonna put it right here. Oh, let me make sure it's actually right there. And I'm gonna tighten it down using these gizmo abilities. And I'm gonna do something like this. Now there's not a lot to reflect, but should be fine. Now I want you to pay attention to this one, and I'm going to click generate lighting. You see what happened? Anything that was metal received proper lighting. It's not looking like it's being specced out. It's reacting more correctly to the environment, right? That's basically what is the issue. Is when you see something is being a bit weird, it's often because you're missing out some reflection probes. So let's do that to all of them. And let's do generate lighting. Notice him. See that? See the floor react differently, and they'll react differently as well. So what I'm going to do, I'm going to pause the video and have just one big one. So I've added reflection probe to the environment. A few more things to know about reflection probe is the placement of it does normally matter. because it is the height that defines where the reflection probe will be capturing it from. So you can see if I keep moving it, say to the back here, and I do that by clicking this move the selected objects, click bake, you can see that there are changes in the reflection of everything that happens. So if I go around here, or maybe I go to this more bright light, you can see there are changes. So sometimes you want to look at what you're doing and kind of place the reflection probe exactly where you think you want it to get the desired effect you want. Another thing to keep in mind, I'm not gonna get too complicated, but you can also click box production, which has a different effect when you do the reflection probe, right? You also have the opportunity to control the importance. Now the important, what does that do? If you have multiple light probes, you want to have some overriding ability. So as it says in the importance, I think the higher it is, the more priority it gets. I think it's something like that, or the lower. It's one or the other. So if you want certain items in your environment to have a higher priority because they need a different effect to it, but you don't want the big light probe, reflection probe, to have any effect, you would then use importance. So for example, let's say I have this one and I want the one in the back to be more reflective for whatever weird reason. So I put it there and I click bake all reflection probes. But also the placement matters, because this one is closer to it, so it will also look differently, because he has his own reflection probe very close to it. So like TVs or mirrors, you would often place them closer to the surface because they are very reflective, and you will click the bake lighting to kind of get a different look to it, right? But more importantly, you have more flexibility. So for example, because this light probe, I can then increase the intensity, right? And then I can go down if I want lower priority, or I can go up if I want more priority. So maybe this one overrides this one because this one is on 1, right? And then if that's not the case, maybe this one is 3, it will then override the other one. So that's the basic you need to worry about when it comes to reflection probe. You also have a blend distance. I wouldn't worry too much about it, but basically if there are multiple reflection probes and you want to have a smooth transition, that's a very good thing to use. Okay, and I would never go real time because that's super expensive to pay for and run all the time. So that's also another thing to think about. So what is emissive light? Well, as you can see, emissive light can be used in many contexts. You could use it to light up an environment indirectly without seeing something, to give a soft shadow, soft lighting without shadow. And there are cases where you have an environment that has emissive looking materials, but it is not emitting. That is why we use emissive material, to make it glow a little bit and stand out a bit more. This allows you to create a different look and a different environment. Now you can think about it as a neon light, obviously, but there are some cases where we use emissive lighting as a softbox, as we use in photography, similar to the rectangular light or area light in our case that we have gone through already. It's a very good way to create soft shadows, but as you can see in some of the example videos, it's a very cool way to make a different look and a different visual style as well. But in our context, we want to show you how you can use it, or in what context you can use it differently than what you might think it is useful for, similar to area light, to brighten an area in a cost-efficient way. So we covered light probes and we covered reflection. So there's one more thing I want to cover before I call this episode a day, and that is the emissive lighting workflow as well. So for the emissive lighting workflow, I've already have it in here. This is also advanced, intermediate, because this also covers some other lighting scenarios that you might want to do. So if I click generate lighting now, it takes longer to bake also if you have emissive lighting. So emissive lighting is basically emissive materials, and emissive materials, they are using baked, so they are not necessarily real-time in URP, and in this example, mind you. So what is it? Well, it's basically using an emissive white material called standard specular setup, and it basically has something in the emission. So this is a texture, and this texture can be made in Photoshop, Paint, whatever. It just defines the general shape and form of your emissive material, and also the brightest point. So the white being the brightest, the gray being mid, and the black doing nothing. You can see it here as well. It fades out, and then it's being at the edges of this frame. You can then go into the HDR settings, and you can see down here it says intensity. So if I go down, you see what happens. Let's do a bake lighting and see what happens. It's as if it was off, and it's obviously visible, so it doesn't necessarily look good. Let's say I increase it. It was on 2, right? So let's just increase it to a lot. What happens when I do the bake lighting then? Okay, it gets super bright, right? So that's basically what emissive lighting can do for you. Of course, they are sharing the same material, which means it's really going to keep multiplying because there are 3 of them. But they are quite useful when it comes to creating a cheap soft lighting, basically, in case you don't want to use an area light, for example. So let's say I turn this off, and then I let it bake. You can also notice they are using this as a photography tool in this example as well. So this is also very common to use if you have like a still car render or something, or character in this case. You'll get some nicer diffuse lighting in your scene, but more importantly, you'll also have an ability to create the shape and forms that pops up on your shape if you needed it. The drawback of emissive lighting though is that you get these weird artifacts the brighter it gets in the back. So there's a reason I don't use too much emissive lighting, and there's a reason I don't use too much area light, and they both have pros and cons for sure. If I turn on the area light now and I click general lighting with this emissive lighting, you'll see that it gets even more brighter, and it has a different look to it. Okay, so that's the introduction of light probes, reflection, and emissive lighting. On the next video, we'll cover the next topic and start working our way into intermediate, which is I think it's going to be 3-point lighting. So your challenge for next time is to do 3-point lighting ahead of time using some of the techniques I've showed you. So emissive lighting, area light, point light, reflection probe, light probes. How would you go on and do your 3-point lighting based on what you understand what 3-point lighting is? You might have to look that up. Then I will explain how I go on about it, and I will explain you what it is in the next video. So thanks for watching, and have a nice day.